Hey, what's up, everybody? Today's January 25th, and let's go ahead and get today started by doing another type racer. Wow, I can't type as good as I want to. Okay, well, I've done better. Alright, so let's see what kind of amazing fun times we're going to have with this problem. 2948, make lexicographically smallest array, blah, 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 blah. I've attempted it before. Let's go and reset this. No. Let's carry smallest array by swapping elements. You're given a zero-indexed array of positive integer nums and a positive integer limit. In one operation, you can choose any two indices I and j and swap nums I and nums j if the absolute difference is less than or equal to the limit. Return the lexicographically smallest array that can be obtained by performing the operation any number of times. An array A is lexicography smaller than the array B if the first position where A and B differ. Array has an element that is less than the corresponding element in B. For example, 2, 10, 3 is lexicographically smaller because they differ at index 0. 2 is less than 10, obviously. Okay. So we can swap any number as long as it's within the limit. And if we can do it infinite number of times, that means as long as everything is within the limit, we can sort them. So this is kind of like a sort and replace style thing, right? So as long as they're within the limit, or the difference of the limit, the subsection can be sorted. So it's kind of like components, right? So you have two components here, 1, 3, and 5, and 9, 8, which both can be sorted. I feel like we can identify what they are by sorting. So we're just gonna sort. Right. So we have a sorted set of values. Okay. I feel like all we do is we find everything in a certain rank, then everything in a certain rank, and then place them into the vector, right? So if we have a sorted set of values, it could kind of be separated into a 2D vector style thing. But you first need to identify differences. Right. And by identifying differences, we can use sort to do that. Or sorted. Okay, so how can we identify the values? Right? So from a overhead perspective, we have 1, 5, 3, 9, 8. So we know this is going to be in group 1, and this is going to be in group 2. Just because of the differences. So 1, 3, 5 are all within the limit. So that's group 1. And then 8 and then 9 is going to be in the second group because it's going to be a part of group 2. If we sort it, it'll be actually easier. So 1, 3, 5, then 8 and 9. You can tell the groups just by looking at this, right? So we iterate, identify each number. So we need some way to go back and forth between their group number and their value. I feel like if I use an unordered map, and in that unordered map, we can do, well, hold on. Because I'm going to want all the 1s and then all the 2s, right? Oh, wait, but I haven't actually made a vector to identify what 1s and 2s are. I could do something like vector int result. This is eventually going to be the result values, right? But then I can go nums.size, and we can fill it with 0 for now. And then I can go rank. But we can iterate through sort. And we just say if. So let's start with, wait, how can we do that? Oh wait, so the first value is always going to be 1, right? Because it's sorted. So we can just say result 0 is always going to be 1. If the difference minus sorted I minus 1, right? If this is greater than the limit, then we're going to increase the rank, right? And then other than that, we're just going to assign result I to the rank. Okay. So we have the sorted values and now the ranks associated with them in result, right? So 1 is 1, 3 is 1, 5 is 1. How's that going to help me? I feel like we need some way of going back and forth, saying, if I have 5, what rank is it? It's 1. If I have 9, it's rank 2. But then I also need a list of all 1s. Oh, wait, no, this kind of works. Because this is all 1s, right? If I just iterate through, I'm like, oh, index this. it's a 1. Go, go, go. Once it's different, we begin again. Go, go, until everything's full. But I probably shouldn't have done this and resulted then. Yeah, because result is going to be filled. Ranks. And ranks is just paired with sorted, right? Okay. Now, if we have our set of values, how can I make it so that I'm like going through and I'm like, okay, what is 5? If 5 is rank 1, do 1. I don't want to like look through. So I guess I could use an unordered map to say, to pair an int Wait, how would that help me? If I iterate through sorted, I'm like, okay, 1 is here. Or no. If this is a rank 1, then do the first rank 1. If this is a rank 1, do first rank 1. Blah, 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 blah. So I need to go... Yeah. So value to rank. Unordered map. Right. So we know sorted... No, we know to rank sorted 0 is always going to be 1, which is basically what I'm saying here. And this is assigning the ranks by the index, which I can just do sorted I equals rank, right? So given a value, I can give it a rank. Okay. For int I equals 0 is less than, not sorted, well, I mean, technically we're going through nums. And that was... Okay, so we're going to say we need an index, right? And then we can say, oh, no. We can say on current rank. Oh, no, hold on. If we are on rank 1, it would have to be a part of here to work. Okay, so we're filling in the ranks. So we're like 1. So we insert 1, then we insert 3, then we insert 5. Then we insert 2 and 9. I mean, I just realized this is not right. I feel like we should just place sorted in the correct positions first by rank. But how do you loop through and do that? It's okay. Place first value, right? Which is going to be rank 1. The problem is if we reach the end... Oh, this is of the sorted list, right? Oh, placed first value. Okay. Place. But then we need to go back to the beginning once it's ranked 2. If I said int j equals 0, because we can do it here, right? Oh, wait, no, because then it'll reset every time. It needs to be on the outside. Oh, I don't know what I'm doing. Okay. So we want to say, actually, if, no. If we said J was the rank that we're starting at, right? What if for every connected pair we had an index? Right. And then we just take that value from the index and place it. So if it's a 1, we place a 1, move up the index. So forth and so on. So because we have a unordered map of int file to rank. Right? Rank I. Int rank will give us the number of ranks that we need. I could do something like vector int rank idx with a size of rank starting at 0. So all the ranks, so all the indexes are at 0. We just say, because it's sorted, right? We'd have the first, but it's not in a 2D vector. I have this identifying it. No, wait, hold on. I can just get the starting indexes, right? Because I have the ranks. But instead of setting them this way, I can bring my rank up here. Just have a default thing. Anytime we increase the rank, this is the start of a new rank, right? Okay, and then we just say rank idx.push back I. Oh, but this isn't sorted. Oh, no, it doesn't matter. We want it in sorted. Okay. Okay, so if... So all we need to do is say result I. Or no, we want to go through nums. I mean, that doesn't even matter, but... So result I is going to equal... So starting off at nums I is 0. Right. So we need the rank. So we have the rank index, right? But to get the rank index, we need the rank of the number. So val to rank. Rank. Okay. And val to rank is going to need the nums I. It's going to tell me what rank the value is. Okay. And then I need the starting index from sorted. So rank idx. Okay, so if it's 0 or whatever, it's going to, this is going to give me the starting index of whatever it is. Right? And this is going to be from sorted. Okay. Right. And then we're going to increase the index of the rank, or the rank's position in sorted. That way, when we get to the next one, it should work. Jeez. Let's see. Oh. Let's see. Undeclared identifier result. Did I have a result? I guess I don't. Vector int result. And this is going to be num.size. Okay, let's see where we messed up. 11012. What? Okay, this gives me the index. Sorted I equals rank. Wait, what am I doing here? Eight, 1, 3, 5, 8. Hold on, why am I getting 8 first? Also, why did I get a duplicate 8? It's the same problem with all of them. 1, 1, 2, 6, 7. Whoa, what is going on? Nums I, whatever this rank's value is. We want the val to rank. This should give me the rank of the first value. This gives me the index of the first rank. Okay. Or whatever rank it is. In here. Why doesn't that work? I mean, sorted shouldn't be messed with, right? Sorted. We have ranks I. Ah, man. One's got really messed up somehow. Hold on. For auto rank IDX. Or no. Hold on. Let's see what's going wrong. So we have 0 and 3 in sorted. Okay, index 0, index 3, those are both correct. For rank 0 and 1. Wait, how am I identifying the ranks? Rank 0. If it's greater. If the difference is greater. So it starts at rank 0. Yeah. Okay, that's good. Val to rank. One. It only associated one value. Where am I doing val to rank? I'm not. So we have sorted. This, it identifies ranks I equals rank. So val to rank. The value that I'm working on right now equals. How did this break it? Nine is 1, 8 is 1, 5 is 0, 3 is 0, 1 is not 1. Yeah. Whew, look at this mess. Okay. So, this is still kind of oven. Hold on, let's... Yeah, I think this should work, though. Oh, it works. Wow, that was a tough problem. Okay, so... The problem was is that I wasn't filling them in my hash map. Go ahead and clean this up a little bit. I really like having all my values, variables, data structures in one place. That's a little better. Anywho, all right. So that's how I decided to solve the problem, I guess. I basically ranked the values, found the placement, mapped everything together, and then iterated through the mapped structure in order to replace the smallest values first in each rank until it was filled. And this should be basically O of N because I'm not jumping around. I'm just placing them as they go. I mean, this might slow me down a little bit, but yeah. Anyway, thank you for joining me all. I hope you all have a wonderful evening. Peace.